Hello everyone, welcome back. In my last video, I started chapter 1, function, unit 1. In that, you learned about algorithm, program, subroutine, function with respect to programming language, function specification, then parameters and arguments, parameter without type, parameter with type, and recursive function. Then finally, you learned static definition and dynamic function definition. Today, you're going to learn interface versus implementation. What is an interface? An interface is a set of action that an object can do. Do you remember operating system definition? Yes, an operating system acts as an interface between user and the hardware. Now you got an idea about interface? Right. For example, when you press a light switch, the light goes on. You may not have cared how it splashed the light. Naturally, right? When you switch on the light, just you will see whether light is there, that is power is there or not. Right? Whether light is fused or not. That's all. You don't care about how it works. In object-oriented programming language, an interface is a description of all functions that a class must have in order to be a new interface. That means, in our example, anything that acts like a light should have a function definition like turn on function, turn off function. I'll give you an example, right? We will see here. Operating system. Word and user. Word is a software, right? Suppose, for example, you want to open Word. What you will do? Your user is nothing but object, right? Word is nothing but implementation. That means you want to implement, you want to open Word. So what you will do? User will click a Word icon through operating system, that is interface. Through interface, it will execute. Now you understood? See here. Switch on. Implementation is nothing but turn on and turn off function. Wire is an interface. Object is nothing but electricity. So you will get the output. Understood? Right? Okay, we'll go back now. So here you see the purpose of interface is to allow the computer to enforce the properties of class type T. Right? Suppose you see type T is an interface. It should have function like X, Y, Z, etc. Okay, type T is an interface. It should have function X, Y, Z, etc. Right? Understood? See, a class declaration combines the external interface with an implementation of that interface. An object is an instant created from the class. I will explain with the example. Okay, see this example. I think this is what program? A class program. Okay, class, what is the name of the class? Simple. Simple is nothing but interface, right? And public, int a comma b is nothing but attributes, right? You all know class consists of attributes and behavior. Function and the behavior. Attributes and the behavior, right? Add. Int add. So this function will perform addition. This function will perform subtraction. Both are considered as implementation. Right? Now here what you're going to do, using this interface, simple, I'm creating an object. And creating an object. Why I have to create an object? To access this function. Okay, if I call this function, then only this function will be implemented. Otherwise, simply it will stay as it is. This will not get implemented by itself unless you call. Right? Similarly, I created an object X. Using this object, I'm calling this add to perform addition. Using this, I'm calling subtraction to do subtraction. Understood now? We will go back now. Right. Now we will see the definition again. A class declaration combines the external interface with an implementation of that interface. An object is an instant created from the class. Instant created from the class. That means this, see, this is interface and you create an object. Object is also called as instance, right? Right. The interface defines an object. Interface will define an object. Visibility to outside world. See, this is interface. Define an object. Create an object, right? Fine. The difference between interface and implementation. Now see the difference. Interface. Interface just defines what an object can do, but won't actually do it. Implementation. Implementation carries out the instruction defined in the interface. I'll explain with the example, right? Same example I'm going to use. Now here you see, this is interface. Just it defines an object. See, this is an interface. I'm defining an object. But simply I have defined only object, right? But it won't actually do anything. But implementation, see here, implementation carries out the instruction. All the instruction given here, defined in the interface. See where you defined this implementation inside the interface. So using this object, I call the implementation to carry out the job. Understood, everyone? So in object-oriented program, classes are the interface. Classes are the interface, and how the object is processed and executed is implementation. See here, object-oriented program, classes are the interface, right? How the object is processed, and executed. See, using this only you are executing, right? So how the object is processed and executed is implementation. Now is it clear now, everyone? Right. Now characteristic of interface. Characteristic of interface. The class template specifies the interfaces to enable an object to be created and operated properly. We will see the same example. Now here you see, what is the definition? A class template. This is class template. Specifies an interface. It specifies an interface. To enable the object, now here you see, this is class name, this is an object. So this class template enables an object to create and operate properly. So using this interface, you create an object. What is the second one? An object attributes. This is object attributes. This is object. This attributes and behavior. These are behaviors. Is controlled by sending the function to the object. Who controls this? This object only controls attributes and behavior. Is it clear, everyone? See here, an object attributes and behavior is controlled by sending the function to the object. You are sending the function to the object. For example, let's take the example of increasing car speed. Okay, here you see engine. Inside the engine, see, this is the function of engine. Get speed. This is implementation. Required speed. How much speed you require, right? You press the accelerator. If yes, it will return. Otherwise, nothing. It will pull the fuel, right? See here, the person who drives a car does not care about the internal working. He doesn't care about internal working, right? Just he presses the accelerator, it goes on, right? To increase the speed of the car, he just presses the accelerator to get the desired behavior. Here, the accelerator is the interface between the driver and the engine. So driver is calling or invoking the object. He is invoking the object. And the engine, the called object, right? In this case, the function call would be speed, that is 70 kilometers per hour. This is the interface. Internally, the engine of the car is doing all the things. It's where fuel, air, pressure, and electricity come together to create the power to move the vehicle. All of these actions are separated from the driver. These actions are separated from the driver, right? Who just wants to go faster. That's all. His aim is to go faster. Thus, we separate interface from implementation. Interface is separate from implementation, right? Let us see a simple example. Consider the following implementation of a function that finds the minimum of 3 arguments. Minimum of 3 arguments. Okay. So now you see x, I had given 3, y 4, z 5. Let minimum of 3 numbers, that is x, y, z, all are variable, is equal to if x is lesser than y. What is x value? X value is 3. Lesser than y. Y is 4. So definitely 3 is lesser than 4. So the control goes inside. If x is lesser than z, what is x? X value is 3. Lesser than z, 5. Okay. Now both the conditions are true. So it will execute this. What is x value? 3. So minimum of these 3 number is 3. That is x. Is it clear? Is it clear now? Suppose, see, for example, now here we will give x is 13. Okay, now x is 13, y is 4. 13 is lesser than 4? No. Condition is false. So first here we have to see, right? 13 is lesser than 4. Condition is false. Then it will go inside. Now here 13 is lesser than z. What is z? 5. Right? So here the condition is false. So directly it will go to this place. Okay. Now what is y? Y is 4. What is z? Z is 5. So 4 is lesser than 5. Condition is true? Yes. So what is y value? 4. So when you compare these 3 values, y is the smallest number. Is it clear? Everyone? Till now, any doubt? If you have any doubt, you can go through the video again, right? Next topic is pure function. Our next topic is pure function. Pure function are functions which will give exact result when the same arguments are passed. For example, the mathematical function sin 0. So whenever you pass 0 to sin function, it always results 0. Whenever you pass tan 45, it will give 1. Right? So this means that every time when you call the function with the same arguments, you will always get the same result. See, whenever I pass 0 to sin, the output will be 0. Whenever I pass 45 to tan, output will be 1. So a function can be a pure function provided it should not have any external variable which will alter the behavior of that variable. That means the function should be pure function. The external variable should not alter this. Right? Till that time, this function will be pure. For example, let's square x. Return x into x. When x is 5, 5 into 5, 25. So, whenever you repeat the same process, when you give the value 5, automatically what will happen? 25 will be printed. The above function square is a pure function because it will not give different result for the same input. For the same input, it will not give different result. There are various theoretical advantages of having pure function. One advantage is that if the function is pure, then if it is called several times the same arguments, the compiler only needs to actually call the function once. That means what compiler will do, when you pass the same value, the same output will be given. So compiler will call only one time. It will know this value will have this output. Okay, right? Let's see an example. Let I is equal to 0. If I is strlen of s, strlen last year itself you learned string length of s is 1. Then do something which does not affect s, I plus I. Okay. So if you compile this program, what happened? I is lesser than str of s. Str of s, length is 1. So I is lesser than 1. Then it will do something, right? Plus plus I. Now here if you notice one thing, you are incrementing I, but you are not disturbing s. Always s will be 1. Okay, now here you see. If it is compiled, str of s is called. Each time the strlen needs to iterate over the whole of s, only s. Each and every time strlen of s is 1 only. So if the compiler is smart enough to work out that strlen is a pure function and that s is not updated in the loop. S is not updated here. Okay, only I is updated. Fine. Then it can remove the redundant extra call to strlen and make the loop executes only one time. So this will execute only one time, right? From this, what we can understand, strlen is a pure function because the function takes one variable as a parameter and accesses it to find its length. This function reads external memory but does not change it. So it will read external memory, but it will not change it. And the value returned derives from the external memory accessed. So only one time the function will read, right? Evaluation of pure function does not cause any side effects to its input. Side effect means change to the input. Is it clear, children? Right? So up till this, if you have any doubts, you can ask me in the online class. Okay, children? See you. Bye.